Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Tunneling protocols are essential to the design of secure, private networks built on top of public infrastructure. These protocols allow entire network sessions or data flows to be encapsulated within other protocols for the purposes of routing, isolation, or protection. In modern networking, tunneling is used extensively in virtual private network deployments and remote access solutions. Whether connecting branch offices or securing a mobile workforce, tunneling plays a critical role in protecting data while ensuring that traffic reaches its destination. For the Network Plus exam, understanding tunneling and secure transport protocols like generic routing encapsulation and Internet protocol security is essential for answering questions in areas related to virtual private networks, encryption methods, and secure site-to-site connectivity. Generic routing encapsulation, abbreviated as GRE, is a tunneling protocol that allows one Layer 3 protocol to be carried inside another Layer 3 protocol. It is most often used to encapsulate IP traffic within another IP packet, although it supports other protocols as well. GRE adds its own header to the original packet, wrapping the data with routing information that allows it to travel through a tunnel between two endpoints. It is not inherently encryptive, so it does not provide confidentiality or protection on its own. Instead, it is valued for its simplicity and its ability to transport a variety of network layer payloads between devices. The behavior of a GRE tunnel is similar to that of a dedicated point-to-point link between two routers. When configured, it creates a logical interface at each endpoint that treats the tunnel as a direct connection, regardless of the underlying network path. This allows IP traffic to be routed across the tunnel using traditional routing protocols. GRE encapsulates packets by placing an additional IP header and a GRE header in front of the original packet, which is then transmitted across the network. Because the payload remains intact, GRE tunnels can carry multicast traffic, routing updates, or IP version 6 packets over an IP version 4 network. Use cases for GRE include building site-to-site virtual private networks, transporting non-IP protocols, and enabling dynamic routing across tunnel interfaces. One of the most common applications is combining GRE with Internet protocol security. In this hybrid setup, GRE handles the encapsulation, while IPsec provides encryption and authentication. This allows organizations to transmit complex protocol traffic securely between remote networks, even when the intermediate network is untrusted. GRE's ability to encapsulate non-standard traffic makes it especially useful in complex routing environments or when transporting IP version 6 across IP version 4 backbone. Internet Protocol Security, or IPsec, is a suite of protocols designed to provide confidentiality, integrity, and authentication for IP traffic. Unlike GRE, which focuses on encapsulation, IPsec is concerned with protecting data. It operates at Layer 3 of the OSI model, meaning that it can secure any traffic that uses IP, including both TCP and UDP sessions. IPsec is used in site-to-site virtual private networks between gateways and in remote access scenarios where clients connect securely to a corporate network. It works by applying cryptographic operations to the IP payload or the entire IP packet, depending on the mode being used. IPsec includes two primary protocol components. The first is Encapsulating Security Payload, or ESP, which encrypts the packet contents and optionally authenticates them. The second is Authentication Header, or AH, which provides integrity checking and source verification, but does not encrypt the data. ESP is more widely used because it supports both confidentiality and integrity. AH is rarely used alone because it does not provide encryption. On the exam, you may be asked to distinguish between these components and select which one is appropriate for a given use case. IPsec supports two operating modes, transport mode and tunnel mode. In transport mode, only the payload of the IP packet is encrypted and authenticated. The original IP header remains intact, so the packet can be routed normally. This mode is often used for end-to-end communication between two hosts. In tunnel mode, the entire IP packet, including the original header, is encrypted. A new outer IP header is then added to route the packet to its destination. Tunnel mode is the standard for site-to-site virtual private networks because it allows entire networks to communicate securely through encrypted gateways. Establishing an IPsec tunnel requires secure negotiation of keys and session parameters. This is accomplished using the Internet Key Exchange Protocol, abbreviated as IKE. Internet Key Exchange negotiates a secure communication channel between the two endpoints. The process takes place in two phases. In Phase 1, the endpoints authenticate each other and establish a secure management channel. In Phase 2, they agree on the specific parameters for the IPsec tunnel, including the encryption algorithms and keys. This process is automated and ensures that sensitive information is protected from interception during setup. Network address translation, or NAT, can interfere with traditional IPsec traffic, particularly when using protocols like ESP that do not include port numbers. To address this issue, IPsec includes a feature called NAT traversal, or NATT. NAT traversal encapsulates IPsec packets inside user datagram protocol packets using port 4500. This allows them to pass through NAT devices without being dropped or modified. NATT is essential for ensuring that IPsec tunnels can be established from behind routers performing address translation, such as in home or hotel networks. While GRE and IPsec are both used for tunneling, they serve different purposes. GRE is a flexible encapsulation protocol that supports a wide range of Layer 3 traffic types but does not provide encryption or integrity protection. IPsec, on the other hand, provides robust security for IP traffic but is limited in its support for non-IP payloads and does not support multicast traffic well. When used together, GRE encapsulates the traffic while IPsec secures it. This hybrid approach is common in large networks that require both flexibility and protection. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Tunneling and encryption are often used together in secure networking, but they perform different functions. Tunneling wraps original packets inside a new outer packet, allowing them to travel through an intermediate network as if they were regular IP traffic. This makes it possible to connect distant networks or carry non-routable data across public infrastructure. Encryption, on the other hand, protects the confidentiality and integrity of the data being transmitted. It ensures that even if a packet is intercepted, its contents cannot be understood or altered. In secure virtual private networks, tunneling and encryption are often combined to provide both reachability and protection. The exam may test your understanding of which protocols offer which features and when both are required. Setting up an IPsec tunnel requires careful configuration. Administrators must define the tunnel endpoints, also known as peers, and specify how the two sides will authenticate each other. Most commonly, this is done with a pre-shared key, but digital certificates can also be used. Next, the encryption and hashing algorithms must be selected. These determine how the data will be encrypted and how its integrity will be verified. Finally, the tunnel itself must be configured, specifying which traffic should be encrypted and routed through the secure connection. This could be based on IP ranges or application-level rules. Misconfiguring any of these steps can cause tunnel negotiation to fail or result in insecure communication. IPsec uses specific protocols and ports for its operation. Encapsulating security payload uses IP protocol number 50, while authentication header uses IP protocol number 51. Unlike TCP or UDP, these are protocol identifiers in the IP header, not port numbers. For key exchange, IPsec uses the Internet Key Exchange Protocol, which operates over UDP port 500. If network address translation is involved, Internet Key Exchange packets may be encapsulated in UDP port 4500 to support NAT transversal. These details are important when configuring firewall rules and are frequently tested on the certification exam. Generic routing encapsulation introduces its own overhead to network packets. Each encapsulated packet includes a new IP header and a GRE header, which increases the total size. This can cause the packet to exceed the maximum transmission unit of the path, leading to fragmentation or packet drops. To address this, administrators may need to adjust the maximum transmission unit manually or enable path maximum transmission unit discovery. If these adjustments are not made, traffic through the GRE tunnel may be unreliable or inconsistent. Understanding the trade-offs of encapsulation is key when planning secure tunnels and answering exam questions related to packet flow. In addition to site-to-site tunnels, IPsec can be used for remote access virtual private networks. In this scenario, a client device, such as a laptop or mobile phone, establishes an IPsec tunnel to a central gateway. This allows the user to access internal network resources as if they were physically present at the office. Remote access configurations often use client software that handles authentication, tunnel creation, and routing. These tunnels may also implement split tunneling, which allows only internal traffic to go through the tunnel while public traffic is sent directly to the internet. This reduces overhead on the corporate network and is an important concept to understand for the exam. Troubleshooting tunnel connectivity involves checking several layers of the network stack. First, confirm that each endpoint is reachable using basic tools like ping or traceroute. If the devices cannot see each other, the tunnel will not come up. Next, verify that the encryption settings match on both sides, including algorithms, pre-shared keys, and Phase 1 and Phase 2 parameters. Firewalls must allow the required protocols and ports, including Protocol 50 for encapsulating security payload and UDP, port 500 for Internet Key Exchange. If NAT is present, confirm that NAT transversal is enabled and that UDP port 4500 is open. Logs and status indicators from the devices can provide insights into where the process is failing. Monitoring and logging are critical for maintaining tunnel health and detecting issues. Many network devices provide status dashboards that show whether the tunnel is up, when it last rekeyed, and how many packets have passed through. Logs can show negotiation failures, such as mismatched keys or unsupported algorithms. Alerts may be triggered if a tunnel goes down unexpectedly, if a rekey fails, or if traffic volume suddenly spikes. These tools help administrators maintain secure and reliable connections. In the context of the exam, you may be asked to interpret log messages or identify the cause of a tunnel failure based on given symptoms. The Network Plus certification may ask you to identify the correct use of GRE, IPsec, or a combination of both in specific scenarios. You could be asked which protocol is used for encrypting site-to-site traffic, or which tunneling method allows for dynamic routing and multicast support. You should be able to match protocol numbers, such as 50 and 51, to their respective components and identify which ports must be allowed through a firewall to enable secure tunnel operation. The exam may also include questions about the negotiation process, requiring an understanding of Internet Key Exchange phases and settings. To summarize, generic routing encapsulation provides the ability to tunnel one Layer 3 protocol inside another, making it useful for transporting a variety of network traffic types. Internet protocol security adds the encryption, authentication, and integrity checks necessary to secure that traffic. While each can operate independently, they are often used together to create flexible, secure tunnels that protect data while enabling complex routing scenarios. Both technologies are central to virtual private networks and secure site-to-site communication. Mastering the roles, protocols, and ports associated with GRE and IPsec will help you answer exam questions confidently and manage real-world networks effectively. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.